What's up, guys? This is Michael with Michael Talks Metal, back for some more talk on some metal. Woo! You guys ready? I am. Let's jump in. Our video today will introduce Invar and Kovar, well-known examples of alloys that are used for applications involving control of thermal expansion. Both are trademarks of Carpenter technology. And so let's start with just a little bit more about expansion. Metals generally expand with increasing temperature, and it is expressed as the coefficient of thermal expansion, CTE for short. The units are in English and would be expressed as inches per inch per degree F times 10 to the minus 6. Got that? Another way to say this is the CTE is how many millionths of an inch. A 1 inch dimension changes for every degree of temperature change. Sounds pretty simple. Things are more complicated in that the CTE also varies with temperature. And so to keep the math a little easier for us, and to make better comparisons, the mean or average CTE over a range of temperatures can be used. Tables of data show the mean CTE for the temperature range of interest. With this data, we can compare two materials, or we can make the calculation of how much a dimension will change with the change in temperature for an alloy. An ordinary steel or aluminum alloy has a mean CTE of about 12 times 10 to the minus 6, or 0.00012 inch per degree in a temperature from 70 to 300 degrees Fahrenheit. So if we have a 1 inch part at 70 degrees Fahrenheit and heat it to 170 degrees Fahrenheit, it would measure 1.0012 inches at 170 degrees. It grew by just over a thousandth of an inch. But what do we do if we need to minimize any changes with varying temperature, or if we want to match expansion to a different material? Back to our alloys, Invar and Kovar. Both are used for their expansion characteristics and are two of the more widely used in this category. Invar 36, UNS K93600, is essentially 36% nickel and the balance iron. CTE is 1.17 times 10 to the minus 6, 1/10 that of our carbon steel or aluminum example. This alloy is used where stability with temperature change is important, such as electronics, aircraft controls, laser, and optical systems. We could also join it to a metal with a higher CTE to generate motion like an old-style mechanical thermostat switch. A free-cutting version, UNS K93601, has 0.20% selenium added to aid chip formation in machining of parts. ASTM B573 is a common specification. Kovar, UNS KNK94610, is an alloy of 29% nickel and 17% cobalt with the balance in iron. In this alloy, its CTE characteristics are both consistent over a wide temperature range and compatible with the CTE of many glass and ceramic compositions, making it ideal for forming glass-to-metal seals. Too much difference would lead to breaking the seal or stresses that could fracture brittle glass or ceramic components. Typical specification for Kovar is ASTM F-15. There are other alloys used for specific applications, but these two alloys represent the principles involved. As always, specs for material and for parts often carry additional requirements. And so, it is time to remind you to check the specs. And so this is Michael with Michael Talks Metal, and that's going to wrap us up for today. Thank you for tuning in. And if you made it this far, well, and you haven't subscribed, please think about it, because you must really enjoy metal. Click here. If you've missed any of our previous videos, check them out. Click here. Thanks for tuning in. This is Michael with Michael Talks Metal. I'm out.